All right, we're going to be doing questions 19 through 24, and this is when things get a bit hairier. But I think we can handle it. So, for this first question, it says a gallon of paint will cover 450 square feet. Good to know. An artist wants to paint all the outside surfaces of a cube measuring 12 feet on each edge. What is the least number of gallons of paint he must buy to paint the cube? Well, this is a level 10 question, and this is where we learned about 3D shapes. Level 10, 3D shapes. But it's not a volume question, actually. It's actually a surface area question because he's just wanting to paint the outside of the cube, right? He's not trying to paint it. It doesn't have to do with the inside, which is volume. So really what we're doing is this. We're taking our cube, all right? Let's draw this out. And what we're trying to do is paint all the sides of this thing. We just want to paint it all, paint, 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 paint. And to figure out how much paint it is, we're going to have to know the surface area of the cube. Well, we know this. A cube has 6 sides, and each side's a square, right? There's 6 sides, each side square. So we can find the area of one of those squares. We could just multiply it by 6 and then know the total surface area. So we have 1 square, and the edge is 12. Now the area, if you remember, is side squared. So our area is going to be equal to 12 squared, which is 144. Now there's 6 sides, so we're going to multiply that by 6. And let's see what we get. We get area of this total cube is going to be equal to, well, hold on, I got to put this into my calculator as well. I'm doing it in my head. It's 864 feet squared. And remember how I say squared here because we're talking about two-dimensional space. Now, would 1 gallon be enough to paint this? No. But maybe 2 gallons would be enough because if each one does 450 square feet, and if I multiply that by 2, I now have 900 square feet painted. So 2 is more than enough than what I need. All right, that would be the least number of gallons. 3 is way too much, 4 is way too much, 1 is not enough. Boom, boom, boom. All right, next question. It says here a lot of things. It's pretty intimidating, right? We got this. In circle O show below, diameter AC is perpendicular to CD at point C and chords AB, BC, AE, and CE are drawn. Which statement is not always true? That's a doozy. Now I'll tell you this. This is actually a level 9 question where we learned about circles. All right. And what we're going to do is this. We're going to start with just marking the information given. And what they tell us is this. AC is perpendicular to CD. So we can make this 90-degree mark right over meow. All right. Now, there's actually 2 more 90-degree angles, and that's here and here. You might remember this property, and that's if you have a triangle, an inscribed triangle, and its hypotenuse is the diameter, then you know the inscribed angle is 90 degrees. All right. We actually learned that. So we know that this is a 90-degree angle, and this is also another inscribed triangle right here, so we have another 90-degree angle. So with that information, we can actually start eliminating some choices. First it says angle ABC is congruent to ACD. So ABC is right over Mia, and ACD is right over Mia. That's this angle, right? Now those are both 90 degrees, so we know that is true. Those are 2 perpendicular angles. Now the other one we know is CBA, right? That's once again right over here, and DCB. DCB, BA, oh, and sorry, CBA and AEC, which is this angle, are congruent. And that is true because we know those are both, right? Those are both 90-degree angles because they're both inscribed angles in a triangle where the hypotenuse is the diameter. Woof, mouthful. So now we're down to 2, 50-50. I like 50-50. Now it tells us that ACB is congruent to BCD. So ACB, which is right here, is congruent to BCD, which is right here. Or BAC, which is right over MIA, is congruent to DCB, which is here again. So we're trying to figure out which one of these 2 angles is congruent to BCD. Now I'll give you a little strategy. Check it out. Let's just fill in angles. Like I said, it gets so much easier if you just put your own angles in. So let's make up an angle here. Let's call this 30 degrees. Now if this angle is 30, and we're talking about a triangle, we know if we subtract 180 minus 90 minus 30 using the triangle sum theorem, this angle also has to be 60. Now follow my logic here. This is going to get a little crazy. We also know this angle is a 90-degree angle. We stated that earlier. So if this part of it is 60, then this part has to be 30. So which 2 angles are congruent? Well, that's this, BCD and BAC. So that eliminates choice here. And the only ones that we know are not congruent all the time, we're not sure, is this guy. That's a tough one. That is a tough one. Now the next one says in diagram below, ABC is similar to DEC. Another similarity question. Look at that. So we know we're doing a level 3 question. Level 3 similarity. All right. Now here's some information given. It tells us that AC is 12. It tells us that DC is 7. It tells us that DE is 5. And tells us that the perimeter of ABC is 30. Let's put that in the middle. What is the perimeter of DEC? I'm going to put my X in the middle there. Now I'll tell you this. We do know that the ratio of the perimeters is the same as the ratio of the sides. So what your average person would probably do is like, well, maybe if I do this, 30 over X, that's the ratio of the perimeters, is equal to 12 over 5, right? And that'll get my answer. So if we did that, we would get, let's see, 150 is equal to 12X. And if you divide both sides by 12, we know that X is equal to, let me put that in my calculator, 150, my head, I'm doing that in my head, 12.5. And look at that, it's one of the answer choices. Sweet, so we'd mark that down. But no, that is not the answer. And let me explain why you need to be smarter than this test. And I'll show you here. Let's look at which angles correspond. A should correspond to D. Remember, the order matters. So A and D correspond. We knew that. But now look at this. B corresponds to E, which is here, and C corresponds to C. All right? So hold on. Let me mark these a little more clearly. So the problem with this equation is this. 12 actually does not correspond to 5. Why? Because this is 1 to 2. Remember this, and this is 1 and 3. So these sides don't actually correspond. We also know that because we could look at the what's it called? We could look at this part. A and C does not correspond to DE. Ooh, tricky. So that's why we need to redraw these triangles. They tricked us. Damn it! So let's erase all this bad work. That needs to leave. Now this is why it's really important to 1, mark the angles when you're doing a similarity problem, and then 2, redraw the triangles. So what I would do is redraw ABC as such. Alright, and then we're going to draw our next triangle. This time we're going to be a little more careful so they don't trick us. So B corresponds to E, so that goes here. A does still correspond to D, and C corresponds to C. So now we have the correct angles in the correct places. So 12 corresponds to 7, right? And this is where 5 goes. So that was actually a pretty mean move on the Regents' part. They were trying to trick you. So the real way we should set up this ratio is, so we can still do 30 is to X, but what corresponds is 12 is to 7. Got caught on that one. So we get 210 is equal to 12X. Divide both sides by 12. And let's see what our real answer is. I'm going to just do that in my head. Definitely doing this in my head. Yep, calculating 17.5. And that is the correct answer. Tricky, tricky Regents, huh? All right, we're down to our last 3 multiple choice problems. Now this one says that line 3y equals negative 2x plus 8 is transformed by dilation center of the origin. Which linear equation would be its image, or could be its image? Well, this is once again goes back to level 1, dilations. And what you know is this. When you dilate a line, the image is parallel to the pre-image, right? So really all you're doing here is saying which one's parallel. So we could translate this question as just saying which equation is parallel. So let's find the slope of our first guy. That should be pretty straightforward. 3y equals negative 2x plus 8. Divide everything by 3. And we get y is equal to negative 2/3 x plus, this doesn't reduce, 8/3. So the slope is negative 2/3. So all you have to do is figure out 1, 2, 3, or 4, which one has a slope of 2/3, negative 2/3. And I'll tell you this, let's try number 1. Let's just try good old-fashioned number 1. 2x plus 3y is equal to 5. We subtract 2x from both sides. You get 3y is equal to negative 2x plus 5. Divide everything by 3. You get y is equal to negative 2/3 x plus 5/3. Now the y-intercepts don't matter. I could even not look at those. But you see here, this is the only one that is parallel to the original line. The answer is 1. And this is really a simple question asked in a very hard way. Just saying which equations are parallel. Number 23. This is a really annoying question if you ask me. It says, the circle with a radius of 5 was divided into 24 congruent sectors. The sectors were rearranged as shown in the diagram below. So you have the circle, it gets like broken all apart, it like does this crazy like tooth thing, and then they put them together. Now here's all you had to recognize, alright? So this outside right here is 1/2 the circumference. It's 1/2 the circle, like the outside of it. And this part right here is 1/2 the circle. So this length is just going to be 1/2 of the total circumference of our circle. Because, right, they just cut it up into 24 pieces. This equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of those pieces, so that's half of it. So this is actually a very simple question. It's just so annoying how it's asked, right? So we just have to know the circumference formula, which is given on the Regents, which is 2 pi r. We know that the radius is equal to 5. And so our circumference is going to be equal to 10 pi, which is about 331.4, 3.141, whatever. All right, so it's 31.41. Now since this x just represents half the circle, I'm going to take this number, divide it by 2, and I get about 15.2, but you know what? That's closest to 16. Checkity check, checky check, 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 chew. Annoying question, tricky Regents. Why are you being like that? And then we have number 24. Once again, it's a pretty straightforward question. This is a level 2 question about congruence. Which statement is sufficient evidence to prove that the two triangles here are congruent? So this is level 2, where we talked about triangle congruence. Oh my gosh. Oh my gosh. Let me rewrite that. Triangle congruence. Okay? So there's 5 ways to prove congruence. Side, 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 angle, side, angle, side, angle, 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 side, and HL. We want to see if any of these meets the criteria. So let's check it out. It says that AB is congruent to DE and BC is congruent to EF. Is that enough information to prove the triangles are congruent? Nope. That's side, side, which is way not enough. So let's try this again. The next one says angle D is congruent to angle A, angle B is congruent to angle E, and angle C is congruent to angle F. Now, that does look good, right? But that's actually angle, 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 which is similarity, but not congruence. This is a similarity. So if it said which one proves similarity, we'd be perfect. But it's not. It's asking for congruence. So that guy's out. And then we're down to these two. Now this one says there's a sequence of rigid motions that maps AB onto DE. So if they map onto each other, we know they're congruent. BC onto EF. And AC onto DF. And if all 3 of these sides map onto each other, that is side, side, side congruence. And that is going to be our answer. Now just to check the last one, just in case you don't believe me. This says there's a sequence of rigid motions that maps point A onto point D. That's pretty cool. So we got just the point A onto point D. That doesn't give us much information. AB onto DE, so those are congruent, and then B onto E. Well, once again, we just have angle side. That's not enough. Boom. So the answer is 3. Alright, that is it for the multiple choice. Booze out!